Okay, so good afternoon, everybody. Let's start. So I have already explained to guys how can you use LEDs. Okay, so we have 4 LEDs here. Also, last time I explained how can you use push buttons. Also, I explained how can you connect, how can you put a switch here and use the switch. And that's what we are going to do tomorrow. Okay, so tomorrow we are going to use the switch. Also you are going to use the push button. Today, I'm going to start with buzzer. We have a buzzer here. Okay, we have a buzzer here. By the way, if your board has a sticker like this one, take it off. Otherwise, the sound will be you barely hear it. So just take the sticker off, as you see here. Okay. So I'm going to explain how can you program the buzzer. Okay, this buzzer is used to make sound, some sound. So how first, as usually I do, I'm going to explain number 1 how it is connected. Okay, number 2 how can you program it. Okay, so let's start with the first one. Okay, let's go here. Yeah, so this is the buzzer here, as you see. So this buzzer is actually, as you see here in what is the figure here? Yeah, you can see here, guys. SPK stands for speaker or for buzzer. So the buzzer is connected to PA8. PA8. Also, as you see here, there is a jumper. There is a jumper here in the board. You have this jumper actually can connect. This is the buzzer, as you see here. So the buzzer, it has only one input. So it has only one terminal, as you see here. So one input is connected to the ground, and it has only one input. That's it. Okay. If you wanna, again, why you are gonna use the buzzer? The buzzer is used to make sound. If you wanna make some kind of sound. Okay. So how can I generate a sound? How I can use it? Okay, very simple, very simple. All what you have to do, guys, you have to generate a square wave. That's it. If I can generate a square wave for this pin, so I'm gonna hear a sound. Okay. However, as you know, or as you may know, we as human beings, we can only hear some frequencies. We cannot hear all frequencies. You got what I'm saying? So you have to make sure the frequency here, it is in the audible range, audible frequency range, which usually between 20 hertz up to 20 kHz. Okay, usually it is in this range. So all what you have to do, guys, if you want to generate sound, again, the speaker here or the buzzer, whatever you want to call it, it has only one input, just one pin. Okay, this pin is connected to PA, which one? Yeah, as you see here, PA8. Okay, so in order to use the buzzer, all what I have to do, I just have to generate a square wave here. That's it. I already explained before how can you generate a square wave. Okay, that's exactly what we are going to do right now. However, you have to be careful that the frequency here has to be in a certain range. Otherwise, we cannot hear it. You are not going to hear it. Okay. One more thing, I think, let me clarify here, because this, you may use a buzzer and it may not work because there is a jumper. Hopefully I can locate the jumper. Yeah, can you see this jumper? Very important jumper here. Okay, so this jumper, actually, if you put it this way, as you see here, so you connect the buzzer to PA. Again, I forgot. PB, right? Yeah, PA8. Sorry, PA8. However, if you connect it this way here, so actually you are going to connect it to digital to analog converter. Okay, guys, so very important. You may run the program. I already have a program online. You may run it and you may not hear any sound. Okay, this is because the buzzer is not connected to BB8. Okay, BA8. So you have to make sure the jumper has to be this way. Okay, if you put it this way, it's going to be connected to the digital analog converter. Okay? And so again, all what I'm going to do right now, guys, here, Number one, I told you the buzzer, it has only one input, only one connected to only one pin. That's what I said. Also, what I said, the buzzer is used to generate sound, to hear some sound. Okay. Also, I told you all what you have to do, just you have to generate a square wave. That's it. And similar to what we did before, for this pin, for the pin you are going to use, you have to configure this pin out. That's exactly what we are going to do right now. Okay. For example, if I want to make alarm, you know the police siren, police siren. In order to make something like that, like a police siren, you can tell from the sound there are two tones. We have two tones, one tone, another tone. So I have two different tones. Every tone has different frequency. That's why you hear. So that's exactly what I'm gonna do in this program right now. I'm gonna run two tones with two different frequencies. Every tone, I'm gonna run it for a certain time. Okay. So for example, half a second, I'm gonna run one tune for half a second, and then I'm gonna run the second tune for half a second. That's why you hear for half a second, for half a second, for half a second, for half a second. Okay, that's exactly what I'm gonna do. So how can we do that? Okay, I selected. That's again, you have the board, you have the program, you can play at home. You can play at home. What I'm telling you guys is by changing the frequency. By changing the frequency, you are gonna run different tunes. Okay, I'm not good in music, but what happened to before, some students did a project using the buzzer. They did some kind of songs. Okay, songs. So if you search online, as you know, some songs is just or any music is just a bunch of tunes. You got what I'm saying? Every tune has a certain frequency. So it was very simple. All what they did is, in order to run a music, I'm gonna run a certain tune for some time, certain tune for some time, run some tune for certain time, and so on. If you do this one, you can hear a music. And I want you to, again, you have the board, you have the program. When you go to home, just play with it. How can you play with it? Try different tunes, try different frequencies, and see how it is different. So every tune, you will hear different sound. Okay. So anyway, now I want to make this program the police siren. So for this police siren, as I told you, I'm going to select two frequencies, one 500 hertz and the second one 250. This is for one tune and the other one for a second tune. Is that okay? So if I want to make 500 hertz, that means the period from here to here should equal 1/500 hertz, which should equal 2 milliseconds. Okay, that means the delay here has to be 1 millisecond, and the delay here also has to be 1 millisecond. Okay, same thing here. If I want to generate 250 hertz, so the time from here to here, the time should equal 1/f, equal 1/250 hertz, which should equal 4 milliseconds. That means the delay here has to be 2 milliseconds. The delay here has to be 2 milliseconds. Okay. In the first lab, we did the same thing. We generated the signal. Okay, but this time was 1 second and 1 second. So it's exactly the same thing we did before, but instead of making the delay of 1 second and 1 second, I'm gonna make the delay 1 millisecond and 2 milliseconds. Is that okay? So now, all what you have to do, number one, I need to configure the pin I'm gonna use. I have to configure it output. Number two, I have to generate these two tools. Okay, but there is one thing is missing. You told us I have to run the first tune for half a second, and then I'm gonna switch to the second one. So that's why you hear So I have to run one for a certain time, for example, half a second, the second one for half a second, and then I have to repeat. You got what I'm saying? So how I can do that? So yes, it is easy. I can generate the signal because I have a delay. I can control the delay. Also here it's easy. I can generate this one, but how I can run this one for half a second? How I can do something like that? Very simple. Look here, guys. Okay. So actually, here from here to here is gonna take 2 milliseconds. Okay. So the question is that if I want to run this one for half a second, for example, half second, okay, how many signals I have to generate from this one? how many signals. So I have to generate one. This is 1, 2, 3, 4, 5, 6. So how many cycles I have to generate? You got what I'm saying? So all what you have to do, you have to divide half second divided by half second means 500, right? 500 milliseconds. I'm going to divide it by 2 milliseconds. That means I have to generate 250. I have to generate 250 cycles. Is that okay? So half a second here means I have to generate 250 cycles. So all what I'm going to do now, guys, I'm going to make for loop for 250. And in every iteration, I'm going to generate one cycle. That's exactly what it is. So if you look at the program, number one, I made this function. I call this function initialization to the buzzer. Nothing, you already have this program here, guys, in the course website. So this is the program. Nothing is new here. All what I did here, I just to configure the BA8, just a configuration for BA8 to make it output, exactly similar to what we did before. Okay. And this is a siren. This is a program for the siren. So as you see here, guys, number one, I made for loop here. This for loop should generate the first tune, and then I have another for loop to generate the second tune. So this is tune 1, which is 500 hertz. This one is 250 hertz. Okay, and every one of them I'm gonna run it for half a second. So this one half a second, and then I'm gonna go back to while again to repeat it again. You see it? So here I have a while loop. So here this one half a second, half a second, half a second, half a second. Is that okay? And you can see here what I did here, guys. As I told you, all what I'm gonna do, I'm gonna make a for loop for 250 times. In every iteration, I'm gonna make only one cycle. So one cycle in every iteration. In every iteration, one cycle. So if I make for loop 250, so I'm gonna generate 250 cycles. And this is half a second. Is that okay? In every iteration, as you see here, I'm gonna pull the bin high, bin A8. So I'm gonna pull it high, then I'm gonna wait 1 millisecond, pull it low, wait 1 millisecond. So here, as you see, in every iteration, I'm gonna actually make high 1 second, low 1 second. Is that okay? So every iteration, I'm gonna generate one cycle. I'm gonna repeat this one 250 times in order to hear one tune for half a second. Is that okay? Then this one, everything is going to be exactly same thing for this one here. Everything is the same, but I have to do some changes. Number one, the delay is not going to be 1 millisecond, has to be 2 milliseconds, right? In order to generate 250 hertz, because to make an alarm or a siren, you have to generate 2 different frequencies. Okay, so this is the first difference I made. The second difference is that in order to make half a second here, because now the frequency is less, the interval is bigger, so half a second actually it's enough to make only 125 iteration. How you come up with this number? I'm going to tell you how. Again, if I go back here, yeah, this is the frequency I'm going to generate from here to here. It's going to be 4 milliseconds. Is that okay? So in every iteration, I'm going to generate one cycle. Okay. So if you want to generate half a second, so here how many iteration, how many cycles I have to generate? Very simple. You have to divide half second. You have to divide it by 4 milliseconds, and the result is going to be 125. Is that okay, guys? So yeah, that's what I did. So what I did here. So I'm going to generate 2 millisecond, okay, 250 hertz alarm signal, okay, and I'm going to repeat it 125. Is that okay, guys? Okay, so there are several things here I can say. You are going to see, number one, I'm going to show you now the video. I already recorded the video here. You will hear the sound. You will hear for half a second, half a second, okay? And now again, because I'm just playing, what about if I make this number shorter? If instead of half a second, what do you think the sound will look like if I make it a quarter a second and quarter a second? You get what I'm saying? So the signal is gonna look like more urgent. It's gonna something, you know, when the signal is too urgent, you will see right now also in the video. You have to observe it in the video. You will see I'm just playing, so I can just isolate this number. I make it a quarter a second, quarter a second. So instead of 250, I make it 120. It doesn't need to be exactly the same thing, but anyway, so I just use smaller numbers, and you hear that the signal is more like more urgent. Is that okay? One more thing, for example, when you enter your password to access a room, or when you swipe your card in a machine or something like that, if you make a mistake, usually the system gives you like beep, beep, just to notify you, beep, okay? You can do the same thing here. It's only one tool, right? I think I remember in one exam, I told the students to do something like that. I told them, try to use the buzzer to make beep for 10 seconds. You know what I'm saying? It's one tool, it's not two tools. All what you have to do, for example, if I'm gonna use this tool, okay, if I ask you to do it, for example, for 4 seconds or 5 seconds, beep, something like that. You answer just to notify the user. All what you have to do is exactly the same code here, but for sure, it's not two tools, it's only one tool, okay? But all what you need to know what number you have to put here in order to make it, for example, 5 seconds. Again, it's just 5 seconds, which is 5,000 milliseconds divided by 2 milliseconds. So now it's going to be 2,500. So you have to make it 2,500. Is that okay, guys? Let's see the video. Any questions? Very easy, right? Any questions? Again, we just are generating square wave. That's it. And that's what we have done before, but in a certain frequency, right? I'm going to tell you, there are a lot of funny stories about this one, guys. You know, if you search online, you will find some website use this one to guess your age. Why? Because children can hear more frequencies than old people. As we get older, as we cannot hear more frequencies. So they depend on this technology or this fact. So actually, if you go to the website is gonna run a tool and it's gonna ask you, do you hear it? And then based on that, it can determine your age. You understand what I'm saying? I remember in one lab in the past, it was I asked the student to run different frequencies and just write what is the minimum frequency you were able to hear and what is the maximum frequency. And it was some kind of fun because we found some people can hear some frequencies, but I cannot hear it. You get what I'm saying? So it's going to be some kind of exciting that someone can hear something and I'm not able to hear it. Anyway, you understand what I'm saying, guys? So usually I said until 20K. I think most of you cannot hear up to 20K, I guess. Maybe 16, 17, 18. You can try. I don't know. Maybe some of you have some kind of sober hearing. I have no idea, but this is usually for humans like that. So let's go to the video here before I move to the next topic. I told you here you can find all the videos are here. This is the alarm. It's loud, right? The sound is loud. Let me show you where is the jumper. Look how I connected the jumper. That's what I told you about. If you put the jumper here, okay, you are not going to hear anything, but it's because the speaker is connected to the digital. So this is very serious, okay? So again, I was playing. So now I'm going to change the numbers as I told you. So instead of 250, see what I'm going to do here. I'm going to make it shorter. It doesn't need to be exactly. I made it 125. And here, I don't know how I made this one, but I made it shorter, almost half. I put 62, whatever, okay? And then I'm going to run the program. You'll find the sound is going to be more urgent. You will feel the difference now. It's more urgent, okay? Anyway, any questions? Again, you can go home, you can try different frequencies, you can make beep, as I told you, okay? Anyway, any questions here? Okay, great. Now I'm gonna move to, I told you before, guys, I'm gonna explain everything in this chapter for sure, but I'm not gonna follow the same sequence because I wanna teach first what we need for labs first, okay? Next week, we're gonna have a lab about the use of the keypad and LCD, okay? That's why I'm gonna switch to the LCD right now, okay? As you see here, guys, we have an LCD. Yeah, we have an LCD here. This LCD actually it has 2 lines. We have here, you will see, okay, let me go here, you will see. Okay, as you see here, guys, this LCD, we have 2 lines. Every line can have up to 16 characters. So you can display 16 and 16, line 1 and line 2. Is that okay, guys? Okay. One more thing, very, very important. Look here, guys. So everything I'm gonna explain right now is for this specific LCD. This is specific LCD. Okay. So everything I'm gonna teach right now, I got them from the data sheet of this specific LCD. In your capstone, or maybe in future courses, you may use a different LCD. Okay. So you have to go to the data sheet and see how can you do it. However, luckily, almost all of them are going to be the same way. It doesn't need to be exactly the same thing, but it's the same idea. You got what I'm saying? So anything here, I got it from the data sheet. So if you go to the course website, all the info, this is the data sheet is here for this specific number. Okay. So here is going to tell you how can you program it, how can you connect it, and so on. So you can see here everything about this specific LCD. Okay? So anyway, so this LCD, guys, in order to connect it, how many, again, look here. When I teach any device, number 1, I have to tell you how it is connected. Number 2, how can you use it? That's always has to be this way. So how this one is connected, how many pins we need, okay? So look here, guys, how it is connected. Number 1, I need 1 pin. I need 1 pin for something, it's called RS. I need 1 pin for something, it's a pin is called RS. So what RS means? Okay, I'm gonna tell you what it means. Look here, guys, the idea. The idea is that for the LCD here, you need to send a code, right? This code can be a code for data or it can be a code for a command. Okay? If this code, and the code actually it is 8 bits, always 8 bits. Okay? If this code for data, so it has to be the ASCII of the character you want to display. Okay? So for example, if I want to display letter A, so actually the code, what I'm going to send here in case of data, so data here I mean the characters. Okay? Anything you want to display here, you have to send the ASCII of this character, and all ASCIIs are 8 bits if it is data. Okay? If it is a command, I'm going to teach some codes for commands. But first tell me, what do you mean by command? So again, what I'm saying, what you send to the LCD, either you send a character to display, and that's what I'm calling it data, or you are gonna send a command to the LCD. Okay, what do you mean by a command? Okay, for example, we have several commands. I'm gonna teach all of them. So for example, we have command here, it's called clear LCD. So this is not something you want to display. This is a command. So here you are asking the LCD to clear it. Okay. You have a command like turn off. You have a command like turn on, and so on. So we have several commands. So let me tell you the conclusion. The conclusion is that, guys, what you are going to send to the LCD either data and or command. Command, we have a specific. For both cases, you have to send 8 bits in both cases, right? In case of data, the 8 bits should be the ASCII code for character. So you have to send character by character. If I want to display something like that, welcome to 3130. If I want to display something like that, I have to send character by one by one. So I have to send 8 bits for the ASCII of W, 8 bits for the ASCII of E, 8 bits for ASCII of L, and so on. So you have to send one by one, ASCII of each character. Is that okay? Even space has ASCII. Even any special character has ASCII, plus, minus, a percent, a dollar sign. So all of them have ASCII. Okay. So that's what I call data. That's what I mean by data. If you want to display something, I'm going to call it data. And in this case, you have to send the ASCII of this data. You can also we have some codes. I'm going to explain these codes. These codes also 8 bits and they are for comments. Right? Okay. So I'm going to give you two details. In both cases, we have to send 8 bits. So the question is that because there may be overlap, there may be overlap between data and to comment this, how the LCD can know if you are sending comment or you are sending data? You understand what I'm saying? That means the same 8 bits can be an ASCII for a letter and also it can be a comment. How the LCD can know if what you are sending is a comment or data? Very simple. That is why they made this one here. R and S. So RS is just one pin. This pin should tell the LCD you are sending comment or you are sending data. How? That's what I'm saying here. If you want to send a comment, so you have to put here 0. You have to put here 0 volt or logic 0. If you want to send data, so you have to put here 1. Is that okay, guys? So this pin should tell the LCD if you are sending data or comment. Okay, it's number 1. Any questions? Okay. The second thing is, okay, that's easy. So if you are telling me, if I want to send a comment, just this pin, put 0. Okay, that's easy. I can do it. Okay. If you want to send the data, just to put here 1. That's okay. Okay. So now the question is that, okay, so now I have a code. Listen to me. I have a code to send either it doesn't matter, either comment or either data. In both cases, your code, the code you are going to send is 8 bits. So how I can send this code? How I can send it? Okay. Actually, this LCD, as you can read the data sheet as written in the data sheet. You can use it in two modes. In one mode, we call it 8-bit mode. In the second mode, we call it 4-bit mode. Okay. So what this means? What it means is that in case of 8-bit mode, if you want to connect it in 8-bit modes, so you have here 8 pins. So you have to connect it to 8 pins to your microcontroller. And this is where you have to send the data. So if you have a byte, if you want to send a byte, so I need 8 pins to connect it. If you use it in 8-bit mode, is that okay? The same LCD, you can also use it in case of 4-bit mode. Okay, so what this means? It means I'm going to connect it to only 4 pins, only 4. But wait a second, it doesn't make sense to connect it to 4 because you just have told us your data are 8. So I have to send the 8. So if you connect it to 4, how are you going to send the 8? Yeah, I'm going to tell you how. So what we do, you have to send it in two steps. So I have to send the most significant for first, and then I have to send the least significant first. You got what I'm saying? So again, what I'm saying, if you use this LCD in 8-bit mode, you can connect it to 8 pins. And in this case, when you send the data or you send to command, you can only send it once. Okay. But, okay, so why? Also, if it is in 4-bit mode, so actually, I'm going to connect it to 4 pins. And in this case, I'm going to send, this is the 8 bits are here, okay? So I'm going to send the most significant nibble or the most significant 4 bits first, and then I have to send the second one. But this one is slower, right? This is slower because I have to send it twice, right? It's slower. That's true. It is slower, but it's going to solve a problem. Yes, it's slower, but it's going to solve a problem. What's the problem you have here? The problem I have in microcontrollers, usually I don't have too many pins. I don't have too many pins in order only to give this one 8 pins here. And still I need 2 here. So total, if I use this one in 8-bit mode, so it's going to be 1 here, 1 here, and then I'm going to 8 here. Total, I'm going to need 10 pins. Usually microcontroller, we don't have all these pins, okay? Even if you have them, you want to connect many devices. You got what I'm saying? So it doesn't make sense just to connect the pin here, okay? But anyway, it depends on the microcontroller. So at least for our microcontrollers, we don't have too many pins. But maybe if you have, again, this is design. It's your design. If you have more pins, for sure, if you have many pins available, it makes more sense to connect 8 than connecting 4, because it's going to be faster. You got what I'm saying? Anyway, so, and that's what we are going to do here for this one. So what we are going to do here, guys, for our case, we are going to connect this. We are going to use only 4. 1, 2, 3, 4. Okay. So we're going to have here 4 pins. And these 4 pins here, when I send my data or comments, as I told you, I'm going to send them twice, 4 and 4. Is that okay? So now let me summarize what I said. What I said, guys, we need 1 pin to tell the LCD if you are sending data or commands. We need 4 pins to tell the to send the data to the LCD. Okay. So now we need 1 more here. We call it enable. So why do you need this one? I'm going to tell you why. Look here, guys. You remember before in the first chapter when I told you for memory, you remember when you had memory, I told you there is a pin called read or pin called write, because once you write the address, the memory is not gonna read by itself. There should be a control pin. You have to tell the memory everything is ready now. Memory, you can start reading or you can start writing. You got what I'm saying? Exactly same thing what we are gonna do right now. Okay, so if you already put some value here, 0 or 1, and then you put here some 4 bits here, 1, 1, 0, 1, whatever. Okay, so the LCD is gonna, how the LCD can know that everything is ready and it has to work. It has to, now you can take whatever here, whatever there. Okay, that's why we have this pin. So all what we have to do here, guys, you have to generate a pulse this way. So once you generate a pulse this way, but you have to generate this pulse after you put the correct value in RS, and also you put the correct value here. Once you do this, you generate a pulse. Once you generate a pulse, you are going to tell the LCD everything is ready. You can start writing. Okay, guys, that's how it works. So let me, any questions? So again, the whole story is I have, okay, this is the whole story. Assume I want to display letter A. Okay, if you want to display letter A, number 1, you have to put here 0 or 1. You have to put 1, I'm sorry, because 0 for command, 1 for data. That's okay. And then you have to take the ASCII of A. I think the ASCII is 41, I guess, 41. I guess 41. Okay, assume it is 41 or 60. I think 41. Okay, anyway, assume it's 41. So here we have here 4 and we have here 1, 41. Okay, so and then after that, I'm going to take the most significant 4. I'm going to put them here, and then I'm going to generate a pulse. So now I did only half of the work. I have to repeat again. But this time I have to put this 4. I have to put this 4 here, and then I have to generate a pulse again so that it can take them. It is slower. Yes, it is slower because you have to do it 2 times, 4 and 4. Yeah, but we can. It depends on the application for sure. If this speed is okay for your application, at least we can save some pins. Any questions? Is that okay? Any questions? Okay. So that's why when you read the data sheet, you will see in the data sheet it is written. If you are going to use this one for 8 bits, you have to follow this instruction. If you want to use it for bits, you have to follow this instruction. I told you we are going to use it in case of 4-bit mode. Okay. So now, how many? So now, in order to connect this LCD to the microcontroller, how many pins do we need now? I need 1, 2, and then we have here 4. Total, we need 6 pins. Is that okay, guys? But still 6 is too much to me. Can you reduce them? You get what I'm saying? Because this microcontroller is not a big microcontroller, okay? So still 6 is too much or too many. Can we reduce them? Yes, we can. So what they did here in this design in order to reduce them is, look here, guys. I'm not gonna connect these pins directly to the microcontroller, because if I connect them directly to the microcontroller, I need 6 pins. Okay. So what I did, I connected them to what we call shift register. Shift register. Okay. I'm gonna give you more details. Just wait here. Okay. And so here, this shift register should be 8 bits. 8 bits shift register. So now this one has 1 pin, and then I can take 4 here. So 4 and 2, 6, and there are 2. I'm not going to use 2. I'm not going to use. Okay. Okay. So you are not going to connect the LCD directly to the microcontroller. The answer is yes. Why? Because I want to save pins. If you have more pins, you can connect it directly. And that's what I used to do in last semester. In the other processor, I used to teach in the last processor. So that's what I'm telling you. You should understand. I'm not saying it's always has to be this way. I'm not saying that. Okay. You can see it depends on your design. It depends on how many pins you want to use for the LCD. Okay. But here I want to. Here, if I connect it directly, I need six pins, and I don't want to use 6 pins for the LCD. So the way I did it is, I connected to shift register. Okay. And then connected the shift register to the microcontroller, and I need only 3. I need only 3 bits. So now I reduced it from 6 pins to 3. You get what I'm saying? But again, nothing is for free. Yes, you reduced it from 6 to 3, which may be good because you can connect to more devices, more peripherals. You can connect them to the microcontroller because you can save some pins, but the problem is going to be slower. How? I'm going to tell you how. Okay, guys. So now I give you. So now this is how it is. Microcontroller is going to be connected to shift register. Shift register is going to be connected to the microcontroller. And this shift register, actually, you need only 3 pins. Okay. You need 1 pin for the bit you wanna enter. For example, because if you have, for example, if you have a byte, so you have to take bit by bit. You have to send bit by bit. That's why slower. You got what I'm saying? Shift register. I'm not sure in digital system, you know how this one can work. It's just a series of flip-flops. So this is already hardware circuit is already known, logic circuit. Okay, I'm not sure if you took it before or not, but this is a known circuit. Okay, so you can input. I can input bit by bit. That's why it's slower, much slower for sure. But I can only use 3 bits. So here, I have here some diagram to understand it, but I put it under 7 segment because also we are going to use it in 7 segment as well. But let's focus here. So here I'm explaining how it works here. So this is, and also on the course website, I give you the data sheet for the shift register we are using. So the shift register is actually connected here in the board, somewhere in the board here. You got what I'm saying? It's between. So here what they did, they connected the microcontroller to shift register, and then the shift register is connected to the LCD. How it works, guys, I'm going to tell you how. So for example, if I want to write these 8 bits, I have these 8 bits. And this is, if I want to write them. So I have, what I'm going to do right now, so I have to start from here. Why? Because whatever you are going to put here is going to be shifted. So I'm going to put 1. So let's see how I can do it. Okay, guys. So here, what I want to do here, I want to write these 8 bits to the shift register. As you see here in this figure, the shift register is just a series of flip-flops, as you see here. Okay. So I told you all what I need from the microcontroller, 3 pins. In order to write this one, only I need 3 pins. The first pin, it's called serial data in. This is where, so this one, it's going to be connected to the microcontroller. This is where you have to put, do you want to store, or do you want to input 1 or 0? So this is for data, right? So here, when I input this one, it has to be 1. When I input this one, it has to be 0, 1, 0, 1, 0, and so on. You will see right now how it works. Okay. So anyway, the data you want to write here in this shift register, I'm going to put it here. That's why I put 1 here. Okay, so that's why I need 1 pin here, 1 pin. Okay, the second pin is, we call it shift clock. I'm not sure if familiar with it or not, shift clock. So what happens is that every time I give it a clock, so this one is going to shift, it's going to make a shift. What do you mean by make a shift? That means this one is going to enter here. And whatever here is going to come to here. Whatever come here, come here, come here, come here, come here, come here, come here. Is that okay? So it's going to be, all of them are shifted. So every time I give it a clock, it's called shift clock. So every time I give it a clock like this one, so every bit is going to be shifted. You will see right now what I'm talking about. So anyway, so again, as I told you guys, I have 3 pins. This one is connected to microcontroller. This one is connected to microcontroller. There is another one, I'm going to talk about it later, also connected to microcontroller. However, the output here are going to be connected to the LCD. Okay, guys, I'm going to give you more details. So let's see how it works. Number one, because this is how I'm going to write the code right now. If I want to write this number, so that I want to put it here. I want to put this number here, so that this number is going to go to the LCD. Okay. So if I want to do something like that, how I'm going to do it? Okay. You have to make for loop 8 times. So you will see in the code, I did it. So you have to make for loop 8 times. In every iteration, I'm going to input one bit. So in the first iteration, I'm going to do this one. Second iteration, that's exactly what I'm going to. So look what happens here, guys. This is the first iteration in the for loop. So this one, I'm going to put 1 here, as you see. Okay. Then I'm going to give it a clock. Once I do that, you can see the 1 is here. Okay. This is 1 iteration. Iteration number 2. Iteration number 2. So this time I'm going to take this bit here. I'm going to put this bit here, and then I'm going to generate a clock. So you can see the one was here is going to be shifted. The 1 is shifted, and then 0 will come here, right? Iteration number 3, I'm going to put 1 and generate a pulse. In every iteration, I'm going to put what bit you want to put here and generate a pulse to shift it. Okay, so as you see here, guys. So after I finish everything, you can see now this number is already written here. This number is written here. Okay, but this number is not connected to the output yet. It's not shown in the output yet. Yes, because you have to shift first. Once I shift and finish shifting, now I have to generate another signal here. We call it latch clock. So once you do that, latch clock, so whatever you put here is going to come to here, and then you can see it at the output. That's why you need 3 pins. So I need 1 pin. 1 pin for the data here, 1 pin for shift. And after I finish shifting, or after I finish writing, after you finish writing the 8 pins, now you need only to generate one signal here on this pin in order to transfer, in order to copy this one to this one, and then to the output. Is that okay, guys? So number 1, you should understand, guys, from what I said, you should understand, not always you will need shift register. Okay, you should understand we use it in order to save pins, so that microcontroller can be connected to many devices. Okay, why? How you saved it? Because for sure there is good thing and bad things. For sure, nothing is for free. The good thing, instead of using 6 pins, I'm going to use only 3 pins from the microcontroller. That's a good thing, right? The bad thing is, number 1 is going to be slower. It's going to be slow. Okay, because why? Because I need to put 1 bit shift, put 1 bit shift. So instead of just writing, you can just write. No, it's going to be bit by bit. Okay, so this is bad thing. The other bad thing, for sure, there is some cost there, because you need to buy the shift register. Any question, guys? So tell me again. So, and whatever come here is going to be connected to the LCD. Is that okay? So any questions here before I continue? Okay, now let's talk about programming. How I can program something like that? Very simple. You will see it right now. Very simple. Number 1, I have 3 pins. I'm going to use 3 pins here. So you have to configure these 3 pins out, because this is the 3 pins connected to the microcontroller. So number 1, you have to configure them out. This number 1. Number 2, as I have just told you right now, I need for loop 8 times. I need for loop 8 times. In every iteration, I have to read this value. If this one is 1, I'm going to write here 1. If this bit is 0, I'm going to write here 0. So I should have some kind of a, you will see like a mask, like the mask. Okay. So in the first iteration, I have to check this bit. And then I copy this bit here. Second iteration, I have to check this one, copy it here, and so on. Also, in every iteration, after you copy the bit here, you have to generate this one in order to input this bit. Okay, this should be done 8 times. Okay, every time I'm gonna work on different pins here 8 times. In every iteration, I'm gonna copy one bit here, generate a clock. Okay, then after I finish, after the 8 iteration, I have to generate one here for the latch. Once you do that, you are done. So I'm going to choose the code I did for that. Okay? But before I choose the code, I told you we need only 3 pins. That's interesting. We only 3 pins. Okay. So here, by the way, they actually less than 3. How you are saying that? I'm going to tell you why. Because let me go to here to explain what I want to say here. Look here. Yeah. This is the data. So I'm going to use this one for data. Okay. This is the data. And also I'm going to use, where is the shift? Yeah. This is shift. This is the shift for LCD. Okay. And we have here, we have also shift for 7 segment. So this one is going to be used for shift for 7 segment, because I told you when I teach a 7 segment, I'm going to use the same idea again. I'm going to also use shift register. Okay. And this is for latch. This one is for latch, or maybe the opposite. I need to check now. I don't know if this is okay. Anyway, so I'm telling you it is actually less than 3, because this pin here, the same pin, I'm going to use it for both, for 7 segment and actually for LCD. You got what I'm saying? So for 7 segment LCD, I can use it. I'm going to use the same pin here. Also, this pin here, I think this is a shift, and this is for latch. I think this is for latch. Yes, it's a different one for latch, and this one is for latch. So what I'm saying, guys, here is this one is going to be used for both 7 segment and also LCD. Okay, because you are not going to use both of them, or you are not going to write to both of them at the same time, right? So I can do that. Also for the clock, I'm going to use this one for both of them. But for latch, this one is going to be used for LCD, and this one is going to be used for 7 segment. So for 7 segment and LCD, all what I need, only 4 pins. Interesting. Only 4 pins for the 7 segment, and forget the 7 segment for now, but at least for now, I told you we need 3 pins. The 3 pins are here. This one PB3, and this one for data. This one is connected to data, and this one is connected to latch. Okay. So let me choose a program. How I made this? I made just a function, as you see here. Yeah. So if you go to the diagram, I told you in the course website, you can see the schematic diagram. You can see something like that. It's going to tell you this is the number of the latch. And also on the course website, I put the data sheet for this one. I put the data sheet to understand how it works. I already explained how it works, but anyway, so I put the data sheet for this one. Also, here you can see that's what we need only. We need this one for clock, this one for latch, and this one for data, as I have just explained. Okay. Yeah. So now how it is connected? Okay. Because this is the shift register. The output of the shift register we have here, we have 8 bits output, 8 pins or 8 bits output. Okay. So actually, as you see here, I'm gonna connect this one here to here, this one here to here, and then these 4 are gonna be here. You got what I'm saying? That means if I wanna write something to the LCD, it has to be in this format. Okay, it has to be in this format. Whatever you are gonna write here, these 4 bits, this is the nibble you want to send. And the first one here is RS. And this one here is the enable. Is that okay? So I have to write it in this format. Okay. Anyway, so let me show you how I made it. Okay, so this subroutine, as you see here, this subroutine, write to the shift register of the LCD, because we have two shift register, as I explained before, one for the LCD and the other one for the 7 segment. So I already made this function. You already have this function, as I told you guys. So here, all what you have to do, you have to send the byte. You have to send the byte to this function. You have to send the byte, okay? And then, as I have just explained, you are gonna check bit by bit. How can you check bit by bit? As you see here, and actually that's also what you did in the last lab. I'm gonna make something, I'm gonna call it a mask. So I'm gonna put here 1 0 0 0 0, and then I'm gonna do AND operation. Make sense? In order to check this bit. So in every iteration, so in the very beginning, mask has 1 here. In every iteration, I'm gonna shift it. So here in the first iteration, 1 0 0 0. Okay. Second iteration is gonna be 0 1 0 0 0. Why? Because in the second iteration, I want to check this bit. Third iteration is going to be 0 0 1 because I want to check this one, and so on. So until the last iteration, the one will come here to check this one. Make sense? So I'm going to start. I'm going to put 1 here. Every iteration, as you see here, I'm going to shift it 1 time in every iteration. Okay? So that this one is going to come here, come here, come here, come here, come here until it comes to here. So that in every iteration, I need to check 1 bit. Okay? As you see here, look what I did. I'm going to compare, so I'm going to do AND between the byte you give to. So again, as I told you guys, I'm going to make for loop 8 times. For loop 8 times. In every iteration, I'm going to, as I told you, I have to copy. For example, in the first iteration, I have to copy this bit to this pin, to this one, MOSI. And MOSI, as you see here, is PB5. So I have to write here 0 or 1. Okay, this is based on these values. That's exactly what I did. Look here, guys. Look what I did. Here, I'm gonna do AND between the byte you wanna write and the mask. And if the result is 0, that means this bit is 0. That means I have to write 0. That's what I did. I'm gonna write 0. Very easy. So I'm gonna, in every iteration, I'm gonna check 1 bit. If this bit is 0, I'm gonna write 0. If this bit is 1, I'm gonna write 1. And that's exactly what I did here. Where you have to write 0 or 1 in B5. In B5. Why B5? Yeah, because P5 this is where it is connected to the data. Okay. Any questions? Okay. So in every iteration, I'm gonna write this one. Okay. Second, as I told you, I have, once you write the bit, I need to input it. I need to shift it. I need to input it. Okay. And as I told you, in order to input it, you have to generate a clock this way. On which pin you have to generate this one? In B3. So let me come here. Yeah, B3. This is the clock. Right? That's exactly what I explained. So as you see here, guys, I'm gonna make for loop 8 times. For loop 8 times. In every iteration, I'm gonna work on 1 bit. Okay. If the bit is 0, I'm gonna write 0. If the bit is 1, I'm gonna write 1. Then I'm gonna generate a clock, this one, so that I shift or I input this bit. Okay. So after I finish, so here is going to be 8 times. After I finish, I have to latch it. So I have to generate this one for the latch. Any questions here, guys? Again, if you go back, this is the code, exactly everything I explained here. If I go back here, it's exactly everything. Number 1, yeah. Number 1, you have to check the pin, this bit, and you have to write it here. This number 1. That's exactly what I did. Number 2, you have to generate this one so that the one is going to be shifted, input here. You have to do that 8 times. That's why I have a for loop 8 times. You have to do it 8 times. And then after 8 times, you already wrote everything here, but it's not shown in the output yet. It's not at the output yet. In order to transfer, or in order to copy this one to the output, I have to generate this signal in the latch only 1 time after I finish. So I need 8 iteration to write this number, and then after 8 iteration, I have to generate this one to the latch so that you can see them here. Any questions? Okay, so now Yeah, sure.
For that last slide that you're on, we're going to be using the output enable and that input that's covered up on page number.
Which slide? This one? Yes.
One more. Using the output enable and that
Where is
covered up on page number.
oh, here? Okay. No, this is already connected, okay, by the board. Only you need three pins. You know what I'm saying? This one and this one, and also no, what is the latch? That's it. That's all what you need. But enables are going to be done by the board, okay? And very important thing also, because it may not work with you because of that. Let me go here because I want to tell you. Yeah, there is a very important jumper here. If you look at the jumper, okay. So this jumper, because I told you this port can be used for our microcontroller and other microcontroller, okay? So as you see here, you have to make sure, as you see here, guys, it's written serial and it's written parallel. In our case, because you inputted serial, in our case, so you have to make sure the jumper is here, okay? There is, if you connect the other microcontroller, you have to put it here because it's parallel. It does not use a shift register. You got what I'm saying? You just write right away without a shift register. Okay. So you have to make sure, because if the jumper is here, it's not gonna work. Okay. Everything is okay, but it's not gonna work. Regarding your question about the enable, if you look at this figure, how they made it, look here. When I put the jumper this way in serial, so what actually I'm gonna do, I'm gonna connect 0 to here. So this one is 0. Once I do that, so this one is gonna 0 is gonna come here to enable this one, but it's gonna disable this one, because this one for the parallel, okay, and this one for serial. However, if you connect the jumper here, so actually this one is gonna be disabled and this one is gonna be enabled. You got it? So this is exactly how it is. You have two parts. Ours is here, our microcontroller is here. So you have to make sure this one is enabled, but it's not your work. This is how the hardware will enable. Okay. For us, we have only three. We have to work with only three pins. Any questions? Okay. So now all what I explained. So let me tell you what I explained now, guys. Number one, you should understand how the LCD is connected. Is that okay? The LCD is connected to shift register. The shift register is connected to 3 pins to the microcontroller. Is that okay? Number two, I explained, if you wanna forget how it is connected for now. I have already a function. When I call this function, I can put some value here. That's it. That's what we have. So I have a function. How? Okay, I already explained how, but at least I have a function. Once I send some value to the function is going to write it. Is that okay? Yes, it is serial, but anyway, everything is done by the function. Just the same to do the function is going to write the value here. Any questions? Okay, now, okay, so I told you guys, okay, now the question is that, okay, now I have a function. This function is gonna whatever I send to the function is gonna put it here. Okay, we already have this function. Okay. So now the question is that if I want to write something here, how I can write it? I told you the way you have to do it. So for example, if I want to write a character or a command, okay, the way you have to do it in 2 steps. As I told you, you have to send this nibble first. Is that right? And then for sure, if you're writing data, you have to put here 1 for data, or you have to put 0 here for command. Okay. And then once you finish it, I have to generate a pulse here so that the LCD is gonna take this nibble. And then you have to repeat again with the second nibble. You got what I'm saying? So I have to do it twice. The first time I have to write this nibble here. Also, I have to make sure this one is 0 or 1. Also, I have to generate a pulse here. Okay. To do that, I made a function. Okay. This function is going to send a nibble. So I'm going to send a nibble to the function. The function is going to write the nibble. Okay. And this function actually is going to call the function I have explained right now. So now, this is a very basic one. So this function, guys, this one is gonna send to the shift register. Okay, I'm gonna create another function that is gonna use this function, but the other function is gonna send to nibble, only nibble. Okay, so I'm gonna show how it works, and all what is gonna do, guys, the function is gonna put the nibble here, and then you have to tell me if you are sending to me, you have to tell me if it is a command or data. If it is a command, I'm gonna put 0 here. If it is a data, I'm gonna put 1 here. Is that okay? So all what you have to send is a nibble to the function. This is number 1. And also you have to tell the function if you are sending data or command. Okay, and then based on that, the function should decide either put here 0 or 1. Is that okay? And then after that, here I told you this is the enable. The enable, I have to generate a pulse like this one. How can I generate a pulse? For example, if you send here, if you tell me this is a command, okay, so I'm gonna put here 0. Okay, then I'm gonna send this one to this function, to the shift register. Okay, but this time you have to generate a pulse. That's why I have to put here 0, and then I have to send again after I put here 1. You got it? I am gonna do it twice. One time when I put 0, and one time I'm gonna put 1. So I'm gonna choose a function here. Yeah, this function is called LCD nibble. Okay, so here you sent me here 2 things. You sent me a byte here, but actually when you sent me a byte, I'm gonna take only the most significant nibble. Always this function works this way. Also, you have to send here, you have to tell me if this is data or command. So here is this one 0 for command, 1 for data. Is that okay, guys? So as you see here, what I did here in this function, guys, as you see here, the first thing I have to do, I have to check this one. Do you want to write data or you want to write command? So here I have to check this one. Here, this is for command, and this is for data. Is that okay? And if you look at the code is exactly the same thing. The only difference is the first bit. If it is command, the first bit has to be 0. If it is data, the first bit has to be 1. Everything else will be the same. Okay, so let's see how it works. Okay, so look what I did here, guys. For example, if this is a command, okay, so what I'm gonna do, I'm gonna take the byte you give to me. Okay, I'm gonna mask. I'm gonna put 0 here because you wanna send to this one. So I don't care about this one. So every time you call this function, yes, you are gonna send a byte, but this function is gonna only write the most significant byte. Sorry, the most significant nibble. Okay. So number 1, I'm gonna put here 0. This is number 1. Number 2, look here, because this is 0, 0, 0, 0. Look here, guys. Yes, because this is a command, so this one is okay. It is 0. It's okay, right? However, I have to make sure here in the enable, I'm gonna make the enable 1 before I write it, because I told you the enable has to be 1, and then I have to bring it to 0. Okay, and then I'm gonna write it. So here I'm gonna write this byte, then this one is 0, this one is RS, and the enable is high. Okay, and then as you see here, I'm gonna just change the enable. I'm gonna make it 0 now. Okay, and send it again. So as you can see, it's exactly everything. 0 is here, the enable is here, but just here one time I put here 1, and then one time I put here 0, because this is the enable. I have to do something like that. Okay, so okay, then if you compare between what I did here and what I did here, guys, almost the same. The only difference is that here in this bit, the first bit, in the first bit here it is 0. Okay, so what I'm gonna make high is just the enable here, but here so the code is exactly the same, but the only difference here, instead of 2, I'm gonna make it 3. Very small difference, yes, because the only difference is that here, because this one is 3, so I'm gonna put here 1 and 1. Here, because this one is 2, so the one is gonna be only here. Any questions? Conclusion, to make it very easy. Conclusion, we have a very basic function. This function is called write to shift register. Write to shift register. Okay, so this function is going to write to the shift register. We have another function, we'll call it write nibble. This is if you want to write a nibble, to the LCD. Is that okay? Okay, now what is left? what is left is that I did, this one is gonna do half of the work. Why? I told you guys, if I wanna display letter A, so I have to send 41. Is that okay? In order to do that, I have to send it twice, 4 and then 1. So I have to call this function twice. That's true. So I have to call this function twice. Call it one time to send this nibble, and then I have to bring this nibble to here and then call it again. This is another function. You got what I'm saying? So let's see. So now I'm going to create two functions. One, and that's what we're going to use all the time. Two functions. So this is like helper functions. But now we're going to have two functions. One function to write a command. So once you have a byte for command, it's going to do it for you, write it for you. And then another one to write a character. This is important functions. We're going to use it. Okay. So yeah, look here. They are very simple. Look here, guys. For example, I have another function. It's called write instruction to LCD. So this one. So what this function is doing, guys? This function you have to send to this function the byte for the command, for the code. I told you every code has a byte, and I'm going to teach them has a certain code. Okay. So this function is used if you wanna send a command. This one is used if you wanna send a character. Okay. The difference between them here, I have to send the code for command. Here I have to send the ASCII of the character you wanna display. Is that okay? And this function actually is gonna call this function twice. It's gonna call the nibble twice, as you see here. It's gonna call the nibble twice. So what you give to me here, okay? So what I'm gonna do here, as you see, guys, I'm gonna send this one first, okay? Here, and then here, I'm gonna shift this one here. I'm gonna shift it to here, and then I call this function again. Because I told you this function always is going to display, this function always is going to display the most significant nibble. You got what I'm saying? So in the first here, in the first one here, you give me code. Okay. So this code, I'm gonna mask, I'm gonna keep this one, I'm gonna mask this one, and then I'm gonna send it to the function. Also, I have to send 0 because 0 is gonna tell the function this is for command, right? Then I finished half of the word. And then I have to do it again. But what I'm going to do right now, I'm going to shift this one. I'm going to shift it to here. So because I want to send the least significant nibble, I have to shift it here to make it the most significant. And then I'm going to call this function again. Any questions? That's a very simple function. But this is the one we are going to use all the time. Okay. If you look at the difference between these two functions are exactly identical. The only difference is that this one here and this one here. This is the only difference. Here, because I want to tell the nibble, I am writing command. Here I'm saying I'm going to write data so that this function has to know for RS, for R and S, should I put 0 or should I put 1? So that's what I explained. Okay, guys, any question? So now conclusion. We have two functions. This function, if you wanna send a command to the, if you wanna clear LCD, all what you have to know, what is the code to clear, and then you have to call this function and you have to send this code. That's it. Very simple. Cannot be simpler than that. You have a function. You should know. We have commands for every command. I'm gonna teach you the code for the command. All what you have to do, just send this code to the function. That's it. Same thing here. This one is used if you want to display a character. Okay, like hello, for example. If I want to display hello, so I have to call this one 1, 2, 3, 4, 5 times. So I have to call this one 5 times. In the first time, I'm gonna have to send the ASCII of H, the ASCII of E, the ASCII of L, the ASCII of L, the ASCII of O. Every time this function is gonna display one character. Okay, you have to send the ASCII. Okay, guys. Okay, to make programming more easier. Okay, so now I'm gonna make something like higher level than this one. So this one is used for only one character. I made another function if you wanna display a complete message. So if I have a message, okay, for example, I have something like hello, for example, something like that. This is So here, I'm going to send hello to this function. This function is going to call this one, send H, and then send E, send L, send O. You got it? So here, you can send the whole string to this function. This function is going to keep calling this function to send character by character. Because this is how the LCD works. The LCD, you have to display one by one, character by character. But just to make programming easier for me, I created another function, okay, to display a string. Again, these three functions are very important. We're going to use them all the time. These three functions are very, very important. I'm going to show you how can you use them, okay? The other functions I explained just helper. So just they are used by this function, okay? So here, in this case, you have to make array. You have to make array of characters, as I'm going to explain. You have to send the pointer. You have to send the pointer of this array, okay? And then, as you see here, guys, I'm explaining how it works, okay? So you have here array of characters, okay? When you make array of characters, so here what I'm going to do, I'm going to take the first one here, as you see here. So so here what happens here, for example, if you have hello. So actually, the ASCII of H is going to be here. The ASCII of E is here. The ASCII of L is here, and so on. So what I'm going to do here, as you see, I'm going to take them one by one until I find a delimiter, which is 0. As you see here. So as you see, that's exactly what I did. So what I did here, guys, as you see, you have to pass a function to me. And the way you have to pass a function, you have to pass it as a pointer. This is a pointer to the function, okay? Sorry, pointer to the array of characters, okay, or to the message or to the string. So as you see here, I'm gonna keep looping until as long as it's not 0, because the delimiter is 0. So if I wanna write hello, the delimiter will be 0. It's very easy. So I'm gonna show you how I used it. It's just very easy. So this 0 is automatically added. You don't need to add it. It's going to be automatically added by the C language. Okay. Any questions here? Again, these are the most. We are going to use these three functions all the time. Very important functions. Okay. Again, if you want to send a command, okay, you have to know what is the code for the command, and then you have to call this function. Very easy. If you want to display a character, you should know the ASCII of this character. Send it here. If you want to display a message, a complete message, you have to make array, as you will see right now, array of characters, and then you have to send it here. This one is going to display it. Very easy. Cannot be easier. Okay. Great. The last thing here I'm going to teach is initialization. You didn't talk about it. Yes. Now, based on what I taught now, you know how can you use the LCD, right? But what about the initialization? We need to do initialization. That's true. So what kind of initialization I have to do? I'm going to tell you what kind of initialization. The first one you have to do is that we are using 3 pins. You have to configure these 3 pins as output. That's very easy, right? So if here, let me tell you which 3 pins. I already told you. Yeah. So here, PP4 output, okay? PA11 output, BA11 output, and then BB3 output. So I need to configure these 3 output because I'm going to use only 3 bits, right? That's easy. This is the easy part. Okay. Is that everything? Or I also need to do initialization to the LCD itself. The answer is you need to do initialization to the LCD itself. What I'm saying? So now I need to do two types of initialization. The first type of initialization is I have to initialize, I have to configure the pins, 3 pins. This easy part, right? So we always do it in this chapter, right? Number 2, I have to do initialization to the LCD itself. Okay, I'm going to tell you what you mean. I'm going to tell you what I mean right now, but just give me a second. So if you see here, guys, I created a function. You already have this function for initialization. That means every time you want to use the LCD, you have to call this function 1 time in the beginning to do the initialization for the LCD. If you forget this function, you cannot use the LCD. Okay? You can see I'm doing the same thing for buzzer. For buzzer, I created a function for the initialization of the buzzer. You have to do it before you use the buzzer. I did the same thing for LED 0, LED 1, and so on. Okay. So anyway, let's see what did you do here in the initialization. What did in the initialization, as I told you guys, as you see here, two things. Number one, I have to configure the pins. That's easy part. I'm not going to explain it. All right, so you can understand easily, right? So number one, you need to configure the 3 pins I'm using. Okay, that's the easy part. So number two, the second part here, I have to do initialization for the LCD itself. Okay, what did you do? Okay, what I did here, as you see, guys, in order, number one, I have to write this command to reset, to make a reset to the LCD, reset it. Okay, to do that, number one, you need a delay 20 milliseconds. You need to write this nibble 30, then another delay 5 milliseconds. Then you have to do 30 here for the nibble. You sent nibble 30, 1 millisecond, 30, 1 millisecond, 21 milliseconds. How you came up with this? It doesn't make any sense. 35, 31, 31. How you came up with this? Okay, I didn't come up with it. If you go to the data sheet, that's what the manufacturer of the LCD told me. I just did what they asked me to do. You understand what I'm saying? So I'm going to show you here quickly. So again, this is how can you reset it. First, you have to do reset. So if you go here, it's written here, initialization for the LCD. But they have two initialization, as I told you. This is for 8 if you are going to use 8-bit mode, and this one for 6-bit mode, I guess. So anyway, it's written here. You have to do reset this way before the initialization. I think it's written somewhere. I got it from here. You can find it in the data sheet. Okay, guys. So number one, the manufacturer of the LCDs, they told me you have to send this sequence, because the hardware, once you send this sequence, the hardware will understand you want to make a reset, and then there's a system inside here. So there is some circuit inside here. So this is not a dumb device. The 7 segment, as I'm going to explain later, they are dumb device. What do you mean by dumb? I mean, it doesn't have too much circuit. It doesn't have circuit inside. This one has memory. It has some kind of a system inside the LCD. It has some kind of a system. Okay, anyway. So once I do this sequence this way, the LCD will understand the system inside the LCD is going to do reset. Okay, is that everything? No. They also, if you go to the data sheet, they told me you have to send, you have to send the 4 commands to do initialization. You have to send the 4, just give me 1 second. You have to send the 4 commands. The first command 28. And command 28, you are telling the LCD, I'm using 4-bit mode, not 8-bit mode, 4-bit mode. And then I'm going to configure it as 2-line display. I'm going to configure it as 5x8 font. So every digit here has 5. How many? You know, every character has points. So this is just configuration. So I have to send to 28. After that, I'm going to send 0E. What 0E is going to do? 0E is going to turn the display on. It's going to turn the cursor on. Okay. What do you mean by cursor on? So if you see here, here is this cursor. It's going to turn so that you can. This is the initial values. Okay. So this one. So this command is going to turn the LCD on. This is a command. Okay. It's going to turn the cursor on. It's going to turn the blinking off. Blinking means I'm going to talk about it later, but the cursor can do blinking, like big, small, blinking. Anyway, so usually in the beginning, I don't want to see blinking. Also, this command 01, I'm going to use it later, and we are going to use it in the coming lab. This one is going to clear the display, clear it. In the very beginning, I want to clear. Also, I want to return the cursor to home position. So this one is going to do 2 things. Number 1, clear, and then it's going to move the cursor here, so that when you start writing, you are going to start writing from here. This is the home position. This one here, also, I'm going to talk about it later as well. This one, you are asking the cursor every time I write, you have to move to the right. So for example, if I write A, so the cursor is going to come here. If I write B, the cursor is going to come here. So this is something you can control. This is the command. So this command is going to tell the cursor, it's going to tell the LCD every time I write a character, move the cursor to the right. Okay, I'm going to teach you. Can you move the cursor to the left? Yes, there's a command to do that. Okay, why? I don't know why sometimes you need to move the cursor to the left, but you can do it. But usually, because we are writing English, Every time I read something, the cursor had to move to the right. Anyway, so the conclusion, just I already conclusion, just in one sentence. Okay, I already spent. Okay, sorry, 4 minutes. I'm sorry. So anyway, conclusion, guys. That's what I'm gonna do next time. I explained too many things. Conclusion. Number one, if you want to use the LCD, you have to call this function to do initialization in the beginning of your code. Only one time is okay. One time you have to call this function. Okay. After you call this function, in order to use the LCD, we are going to use these 3 functions. This one is going to be used if you want to send a command. And next time I'm going to teach what kind of command this we have. It's number 1. Number 2, this one is used if you want to display a character and you have to send the ASCII of the character here. This one is used if you want to display a complete message. And the message you have to put it in an array of character and you send me pointer here. That's it. That's what we're going to do next time. So we're going to have 4. We're going to use these 4 functions. These 4 functions, they use another function, helper function. Okay. No question more. That's your question. Okay. Okay. Thanks. Do you want to quiz tomorrow? No? Okay, so I'm not going to make a question.